Welcome to AP Calculus. Our Zoom lessons now return. Let's do this. Yeah, so 5.2, General and Power Antiderivatives. Today's date is Wednesday, December 2nd, 2020. Our objective today, Fiona, go.
Find the antiderivative complex general and complex powerhouse functions.
There it is. So remember, yesterday was just doing the simple version. Today is doing the complex version. So the only difference between the two is the complex version for today is when the inner, the derivative of the inner, is not equal to 1. And because these are harder, these are the more likely to show up on our AP tests. So there are two different methods to do this. There's paying the taxman, which we all remember is probably easier. And then there's the official way, U substitution, which you'll see in college. And there will be a few multiple choice questions, probably 1 or 2 on the actual AP test that say, here are the steps on trying to do U substitution. Can you figure out like what the steps should have been? They force you to do a method. So that's why you do need to know how to use it. But for most of your needs, taxman will be much easier. So there are 3 things that you need to find, 3 easy steps as well. The first 3 things that we're going to find, we need to find U, we need to find taxman, and we need to find U prime. So that should be an equal to sign for each of these. So remember that U is just the inner. So I'll put the inner, and I'll put the inner, the derivative of the inner. I can write a little bit neater, right? The inner. So what is our U in this first problem, Andrea?
Is it 8?
Not quite. So U is the inner, the most inside of everything.
Oh. 4x plus 1?
There it is, yeah. 4x plus 1 is our inner. And then the taxman is always going to be knocking on your front door. I mean, sometimes the taxman will knock on your back door, but it is a cool little way of saying, what is your coefficient, your thing that's being multiplied by outside of your house. So we have a powerhouse function. This is something to the power of 3. That is a powerhouse. And this 8 is not part of that house. That must be the taxman knocking on the front door of that house. So we'll say that the taxman in this case is going to be 8. So I'm going to abbreviate and just say tax is equal to 8. It's a little bit faster, right? And then we need to find the derivative of Andrea's 4x plus 1. We'll leave that up to Teflon. So U prime here, Teflon, is equal to
4.
4. Perfect. All right, so we have all of those pieces. The next thing that you're going to do is you're going to figure out how to pay the taxman. So step number 2 is paying the taxman. Pay taxman. Well, how much do you owe the taxman? You never will pay the taxman a variable amount. You will always pay the taxman an amount of money, some number. And what number is that? It's this tax divided by U. So I'll put over here. It's always going to be your tax divided by your U prime, I should say, not U. So you just make this bottom piece a fraction. 8 divided by 4. You're going to be paying the taxman 8 divided by 4, 2. And what does that look like? What is paying the taxman? Well, you change the 8 into a 2. So you're going to rewrite the integral. The integral is now going to be, instead of 8, it's going to be 2 times the same thing, 4x plus 1, all of that to the power of 3 dx. The only thing that we changed out was the fact that this is a 2 now. In fact, maybe I'll make the rest of this still the original blue color, and the 2 is going to be orange, so it pops out a little bit better. And then finally, step number 3, we do the same thing that we did in our last lesson in 5-1. You actually take the antiderivative. So step 3 is antiderivative. And I said it out loud, but I should write it down as well for this step 2, that you should never pay a variable rate. And I believe in the homework tonight, I think it's tonight, it might be tomorrow night, I have 2 problems at the very end of the homework where I ask, like, look, taxman fails because you pay a variable rate. What's going on? And there is a way to solve those types of problems too. But let's go ahead and do this one. So antiderivative. If I take the antiderivative, again, kind of ignore everything on the inside here. This is just powerhouse. So it's to a power of 3. So let's throw it back to Fiona. What is the first step when we take the antiderivative for powerhouse? Yep, you add 1. So it's going to be 4x plus 1 is still your base. And this is now to the power of 4. And then don't forget to do the next step, which is to divide down. It used to be multiply down, 4 times 2. Now it's divide down. So we divide by 4. So I can just put the 4 over there. I mean, I can make the whole fraction 4, but it's just faster to say 2 divided by 4 for that coefficient. And that third step, that critical step, don't forget, Fiona, your C, exactly. So plus C. And of course, you could simplify that to 1/2. And I can just do that really quickly by going chunk chunk. That's 1/2. And then we're done. We can box it. So that's the pay in the taxman method. I'm going to do the exact same problem down here. So this is still the, you can see it's integral of 8 times the quantity of 4x plus 1 to the power of 3. And this is going to be using the official way that you'll see in college, U substitution. And again, it's used the same time. Whenever your dinner is not equal to 1, that's when you're going to need to use this. So whenever the derivative of the inner is not equal to 1, then you need to use U substitution, or I guess you could use taxman. You need to be comfortable with both. All right, so for this one, you only need to find 2 different things. You need to first find U again, so the same thing. And then the next one you need to find, and I'm running out of room here, so du dx. And notice that this is still saying U prime. This is U prime, but I said it in a different way. I said du dx because I'm, 1, being more formal. I'm using proper math. And 2, this notation du dx, this fraction, is going to be extremely useful in the procedure for U substitution. Okay. Andrea found the inner last time. So let's give it to Teflon. Teflon, what is our U?
Would be 4x plus 1.
4x plus 1. I guess we could have just looked at our last problem. It's the same U, right? And then let's give it to Andrea, our du dx. And if I'm pronouncing it right, the derivative of U with respect to x. I didn't really pronounce that correct. Sorry.
4.
Thank you. Yeah, 4. All right. So that was step 1. What is step number 2? Step number 2 is to get dx, or to solve for d of x. Get d of x by itself. So how do we isolate for d of x? The easiest way to do that is to cross multiply. And notice that 4 is not a fraction, so let's make it a fraction. Sure, 4 over 1, now it's a fraction. Cross multiply. So if I cross multiply, I'm going to do the bottom first because I want my dx on the left-hand side. It doesn't matter, but I just feel like the thing that I'm solving for, I like to have on the left-hand side. So dx times 4 is 4 dx. And on the right-hand side, 1 times du is just du. And then obviously, if we want to isolate for dx, we're going to divide both sides by 4, and dx by itself is going to be 1/4 of du. Or I could say du over 4. It doesn't really matter. I like having the du off to the side because it just makes it flow slightly better. Okay, so that was step number 2. What's step number 3? Step number 3 is kind of the weird part here, but it makes sense logically. So you're going to substitute u and dx. So look back to our original problem. Our original problem had that integral symbol, so I'll rewrite that, the integral symbol. I had an 8, so rewrite the 8. But this 4x plus 1, that's not 4x plus 1, that is u. U is 4x plus 1. So in parentheses here, I don't really need the parentheses because it's just one variable. I can just say 8u to the power of 3. Okay, so I did my substitution with u. And I also need to substitute out the d of x. So I have d of x over here, but I solved for that. That was the whole point of doing step number 2. D of x is 1/4 du. So this is going to be times 1/4 du. And you probably want to rewrite this to make it a little bit easier on yourself. So 8 times 1/4 is 2. So I can say that this is really the integral of 2u cubed du. And it's super, super important to make sure that your variables match up. So look at your original problem. Our original problem had a 4x and a d of x. So the x's and x's matched up. And in this problem, I have a u du. So those variables also match up. Everything is flowing really well. It's working. If I had 2 different variables there, you have suddenly entered multivariable calculus, which is like, what is that, Calc 3. It's too hard. You've done something wrong. This is supposed to be easy calculus for AP calculus. Okay, so we have our integral set up, and you probably guessed it, we're now going to actually take the antiderivative. Let's see, Fiona did it last time. Let's give this one to Andrea. Are you muted still?
Oh, there. Okay. So you add 1, so it'd be 2u to the power of 4 du, and then you divide down, so it would be like 1/2 u to the power of 4 plus c.
U to the power 4, and yeah, so plus c, that equals 1/2 u to the power 4 plus c. Perfect. And then we have a final step, which is why this process is so annoying. You're substituting back and forth, back and forth. Our final step is to substitute u back in. So we know what u was. Up here, that was our very first step. U is 4x plus 1, which means this u right here to the power 4 is 4x plus 1. And I can write out our final answer. Our final answer is 1/2. That was the 1/2. And then u is this 4x plus 1. And that u was to the power of 4. And then don't forget our cake, our plus c. And then we can do a final answer, box it. And notice that we got the exact same answer that we got up here. 1/2 4x to the power, or 4x plus 1 to the power 4 plus c. So same answer. This one is the more rigorous and slightly more tedious process. I do not believe there's a backside to this. Yep, it is blink. So we are done with the notes. Let's look at our objective and zoom out. So our objective, to find the antiderivative of complex general and complex powerhouse functions. How well do you think you can do this objective with a fist of 5? 4, 4, and 4. All right, cool. Well, that concludes that lesson.